Okay, hello. So we're going back to the old tablet recording today. So the 7.1 B, so we're actually going to do the proportions before we do converting ratios, just because I thought this would be a little more straightforward for you, and the other thing we'll do during class. So definition of a proportion is basically when you have two ratios set equal to each other. Now, a ratio, really, most of the time you see that just written as a fraction. So this A over B would be considered a ratio, and C over D is a ratio as well. So this is an example of a proportion. So that is a proportion. Now, one of the properties of proportions is that you can cross multiply and you get another equation. So your algebra teacher last year probably did some sort of circling of the two cross multiplication pieces. But basically all that stands for is that you would say A times D is equal to B times C. B times C is this way. So A times D is equal to B times C, or the cross product or cross multiplying is also equal. So what that allows us to do is look at other ways you can arrange this proportion that is equivalent to this. So proportion equivalence. So one way you can rearrange is you can switch one of those diagonal pieces. So instead of saying A and D here, I put D on top and I put A on the bottom. And then I don't even switch the B and the C. So you can diagonally switch these and it's still equivalent, because if you cross multiply here, you would still get A times D is equal to B times C. So that's considered an equivalent proportion. Okay, another thing you can do is you can flip-flop both fractions. So if I flipped the first fraction, I get B over A. If I flip the second fraction, I get D over C. But again, when you see the cross multiplication, AD are diagonal from each other and BC are still diagonal from each other. So that's considered also an equivalent proportion. Okay, lastly, there is a really complicated version, but I'm not going to do that complicated version. Just know that you can switch the letters diagonally, or you can flip-flop both fractions. Okay, conclusion is, as long as the cross product is the same, then you have an equivalent proportion. So as long as the cross product or cross multiply, I'll just call it cross multiplication. Wow, that's not how you spell that. Multiplication, sorry, is the same, then the proportions are equivalent. Okay. But we are going to use this idea of cross multiplying to solve proportions. Now, you did do some of this last year, so again, this piece of it should be a little bit of a review. We are going to make it more complicated in the coming sections, but this part should be review for you. So using proportions to solve for a missing value. So first of all, it is super important that you recognize proportions have an equal sign between the fractions. So you're only going to cross multiply when you have an equal sign between the fractions. That's when you cross multiply. Okay, so here I see an equal sign between. So I'm going to cross multiply. So I can do x times 5. And if it does help you to draw or circle these like this, please do that. But I get 5 times x, so that's 5x. And then 6 times 4, which is 24. Hold on one second. Okay, sorry. My cat was scratching at the door. All right, so you get 5x is equal to 6 times 4 is 24. And then you're going to solve for x. So I'm going to divide by 5 on both sides to get x by itself. And then honestly, it's a perfectly fine answer to leave this as 25 or 24 fifths. Okay, but you could change that into a decimal if that makes you feel better. And that would be what, 4.8. But you can put it in a calculator too. So 24 divided by 5, and then that's 4.8. Okay, so that's a basic version. Example 2 gets a little more complicated because you have this plus sign in one of the fractions. But main thing, you have this equal sign between the fractions. And then whenever you see a plus sign within the fraction, that just means you need parentheses around that expression. Okay, that also means you will have to distribute when you multiply. Okay, so cross multiplying here, 15 times m, I get 15m. And then 3 times m plus 1, you have to have those parentheses there. So 3 times m plus 1. Okay, so here's my setup. And now whenever you have those parentheses, you do want to distribute. So here I get 15m equals, distribute, I get 3m, and then 3 times 1 is 3. Move my m's to one side, so subtract 3m from both sides. And now I have 12m is equal to, and then this is 3. Now you do have to be very careful here. It's very tempting to divide by 3 because it seems like that'll get you a nicer number. But you do always divide by the number that is with the variable. So I'm going to divide by 12. Okay, so m is equal to 3 over 12. And reducing fractions, you can divide 3 into both of those. So 3 divided by 3 is 1, and then 12 divided by 3 is 4. So the reduced fraction answer is going to be 1/4. Okay, I'm not going to go through this one. This will be part of your assignment tomorrow. But just realize you do want to have parentheses around both of these expressions before you cross multiply. Okay, so the next one. Here, now we're going to start doing quadratics. So we're going to incorporate those quadratics that we have done. Okay, first thing I notice, I have an equal sign between the fractions. That means I'm going to cross multiply. Second thing I notice is I have a plus sign in one of the fractions, so I need parentheses. Okay, and then I'm going to cross multiply. So on this one, I'm just going to rewrite it, n times n plus 17. And then 5 times 12, you can use a calculator, but that is going to be 60. To get rid of the parentheses, you are going to distribute. So I have n squared plus 17n. So n times n, remember, is n squared, equals 60. Okay, and now I'm noticing I have an n squared. So I need to go through the process of solving a quadratic. As you might recall, the first step is to set this to 0. So I'm going to subtract 60 to the other side. And then I get n squared plus 17n minus 60 equals 0. Okay, I'm going to factor this. So I'm going to have n, and I'm going to have n. And then I'll give you one hint, and I'll give you time to try this on your own. But you want things that multiply to negative 60, but combine like terms to a positive 17. So pause for a second and try that on your own. Okay, welcome back. So I'm just going to start listing out possibilities. So 1 times 60, 2 times 30, 3 times 20. This one looks promising because I need a negative 60. So one of those has to be a negative. So if I put a negative 3 times 20 is negative 60, but it'll combine like terms to a positive 17. So that's the one that's going to work. So minus 3 and a plus 20. And then, as always, you split that up into two equations. Okay, add 3 to both sides. Subtract 20 from both sides. And you get 2 answers. Now, because this is simply an algebra question, the negative and the positive should both work. Okay, you can check that just quickly. So maybe I'll do the check here in green. We could have checked the other ones up top here too, but I didn't. So if I plug in 3, I get 3 over 5, and then 12 over 20. And if I divide these both by 4, I will get 3/5. Or if I cross multiply, I get 60. So that checks. You can do the same thing with the negative 20. So negative 20 over 5 plugging in, and then 12, and then negative 20 plus 17 is negative 3. If I cross multiply here, I get 60 and I get 60, so that checks. Or if I reduce this guy, it would be reducing to the same thing. They would both reduce to what, negative 4. So that also checks. So you can check them as well if you're unsure. Okay, so we are going to leave this one again to do tomorrow during class. Okay, next page. So example 4. These is word problems using proportions. So in a local co-ed softball league, the male to female ratio. So as soon as you see male to female, I would write that as a fraction. So male to female is 3 to 4. So that's another way to write a ratio is with the colon. But that just means 3 to 4. So 3 males to 4 females. Now, if there are 160 female players, how many males are there? So you're going to take this ratio and you're comparing males to females. So that means my X is going to go on the top because I don't know how many males there are, but I do know there's 160 females. So this first ratio just helps you organize your thoughts. Okay, now a couple ways you can solve this. You can just cross multiply. So you would get 4x is equal to, and then you can use a calculator, but I believe that is 480. Divide by 4. And then x is equal to 120. Again, you can use a calculator, and that stands for males. Now, the other way you could do it is think about how to scale up 4 to 160. So I can multiply by, what, 40? 4 times 40 is 160. So then I can multiply this by 40 and get the 120 as well. So a couple of different ways you can think about that question, but try to set up in an organized fashion. Okay, example 5. So 10 feet of rope costs $4.95. How much will 15 feet cost? So you can set it up similarly. So we're comparing rope in feet to cost in dollars. Okay, and then you can just obviously put 10 and $4.95. Set that equal to 15, and then how much does it cost? You put the X on the bottom. Okay, and then you can cross multiply and solve that as well, the same exact way. Again, there are multiple other ways to do this problem. So we can talk about that in class if you'd like to. But good job. We'll see you tomorrow.